back at AP Review. We're doing 2016 BC Free Response 2, which is a parametric problem. So at time t, the position of a particle moving in the xy plane is given by the parametric functions x of t, comma y of t, where dx dt is this thing that we're given here. And the graph of y of t, is here, and it's 3 line segments shown in that image, which is much better on the real AP, so use the real AP's image. At t equals 0, the particle has position 5, comma 1, meaning that x of 0 is 5 and y of 0 is 1. Cool, which we can also see on the graph y of 0 is 1. We can't see the x. All right, cool. Part A, find the position of the particle at t equals 3. Okay, so, So part A, right, we want the position at 3, which is going to be x of 3, comma y of 3. Well, one of those two things we can find by visual inspection just looking at the graph, right? So y of 3 is the y value right here, right? Now, since this is a line that has a slope of up 1 over 2, right, it must go, if it goes essentially, like we're looking at a half difference, right? So we're going up 1 over 2. So if we only wanted to go over 1, we'd go up a half and over 1. So essentially what we're looking at is a y-coordinate that is a negative 0.5 or a negative 1/2, right? And you can figure that out any number of ways. So x is the harder one to find, right? So we're going to find x using the first fundamental theorem of calculus. So remember, another way to write x dx dt is x prime of t, right? So if you were to integrate x prime of t with respect to t from the point we know, which is t is 0, to the point we want, which is when t is 3, you'd get x of 3, which is the value we want, minus x of 0. So if you add this x of 0 over and do x of 0, which we know, plus a thing you can make your calculator integrate, you're going to get x of 3, right? Now, for me personally, I know this is a parametric problem, but I didn't put this in the parametric mode. And the reason I didn't do that is I noticed that there's no way I'm going to put y of t in, and you would never want to put the functions on different levels anyway. Like if I put x prime in as my x1t in my calculator, I can't put regular y in as y1t. So I just put this in function mode, and I used y1. And instead of t's, I use x's. So what I'm going to do is I'm going to do function integrate y1 with respect to x, which is the t in this situation, from 0 to 3. It doesn't matter how you get there, you just have to be able to integrate it, and I thought that was the easiest option. So again, what I did is I put that in as my function mode, right? I made sure I was in radians. Obviously, that's always important, right? Make sure you're in radians, and I was in function mode. And then I did math 9, right? So math 9 gives me function integrate. I go to vars, over to y vars, pick function in y1, comma, with respect to x from 0 to 3. And I hit enter, right? That is not ideal. It's still calculating, though. So it's still calculating, and then once it gets its answer, which is a 9.377, blah, 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 I'm going to add to it that 5, right? And I'm going to get that my answer is a 14.377. So I get that this thing is a 14.377, right? So my answer to A is that the position is 14.377, comma, negative 1/2 or negative 0.5, whichever one you like better, okay? That's my part A. Part B, find the slope of the line tangent to the path at t equals 3. So remember that slope is always rise over run, right? Or change over y, change of y over change of x. So B, right, if I want the slope, what they're asking me for is dy dx. But what that is in parametric is dy dt over dx dt, right? Well, dy dt is just going to be the slope of the given graph, which is right here, right? The slope of the graph. And dx dt is going to be the formula that I was given, right? So my dy dx evaluated when t equals 3 is going to be the slope of this line at 3. Well, we already saw that that's a slope of 1/2 because we've already seen rise over run. So it's going to be this 1/2 slope, right? On top of what happens when I plug a 3 in here, which would be 3 squared plus sine of 3 times 3 squared, which is 27, right? And you're going to type all of that into your calculator, right? And when you do, you're going to end up getting 0.5 divided by 9 plus the sine of 27, and you're going to end up getting that this is a 0.050, which is not super satisfying because, you know, you kind of wanted it to be a number that was slightly different than the 0.5 you had there, but there you have it. Part C, find the speed of the particle, right? So the speed of the particle. It's really important when you do parametric problems that you know the formula for speed, right? So the speed of this particle, and they specifically want the speed at t equals 3 again, right? The speed of the particle is going to be the square root of x prime of t quantity squared plus y prime of t quantity squared, right? Essentially, it's the sort of like the hypotenuse of the velocity directions. Anyway, so that's my speed in general, right? So what I want is the speed at t equals 3, right? So speed at t equals 3 is going to be the square root of x prime of 3 quantity squared plus y prime of 3 quantity squared, right? And those are values that I can plug into my calculator, right? I can actually use the values that I have, although we already plugged in you already plugged this value in. So if you wanted, you could have stored 9 plus sine of 27. I'm not sure that it's actually worth it. 9 plus sine of 27 is pretty easy to come by, right? But if you want to store that as something, you can. So when you plug this stuff in your calculator, you're going to get the square root of, I stored it as alpha a, plus, we know that this was a 1/2, so that 1/2 squared is a 4th. And I'm going to get that this is, oh, I didn't square a. That's what I did that was stupid. Hang on. That was not right. I missed my a squared. Thought I had a squared there. Didn't have a squared. Okay, there we go. So I get this is a 9.968 or 9, depending on if you round or truncate. And that's approximate. Cool. Lastly, find the total distance traveled by the particle. So total distance is just integrating speed, right? So, and that's true in all forms of particle motion. So my total distance is going to be integrating this thing, right? So this thing, I integrate speed. So my total distance, and they said from 0 to 3, 0 to 2, that matters. So the total distance from 0 to 2 is going to be the integral from 0 to 2 of the speed. Now, the reason that's relevant, right, is that essentially you're going to have to split this into 2 chunks, right, because this is the part that's tricky, right? So here, the speed, the y prime of t is a constant from 0 to 1, and then it's a different constant from 1 to 2. So what you're going to have to do is split this into 0 to 1 of this thing, right, x prime of t quantity squared plus, in this window, your slope is a -2, right? Down 2, right 1. So when you square it, it's a +4 with respect to t, and then you can make your calculator do that. Plus the integral from 1 to 2. Now here, the slope is a 0, right? No rise. So I get the square root of x squared, or x prime of t quantity squared dt, right? And I can make my calculator do that. So what this is going to look like in my calculator, right? If I type these in my calculator. So what the AP needs to see, right? So in part D, the AP needs to see that you write that the total distance is the integral from 0 to 1 of the square root of x prime of t quantity squared plus -2 quantity squared with respect to t, plus the integral from 1 to 2 of the square root of, and honestly, if I were you, I'd play it extra safe, and when I write it out, I'd make sure that it's clear that this is a 0 squared, right? I'd make it really, really clear that, hey, this is my y prime of t quantity squared here and here, right? But it's different because of the different intervals. So that's what I would write if I were you. I wouldn't even simplify the -2. So then when I put it in my calculator, right? So remember that I called this guy my y1, right? So my calculator, I'm going to type function integrate, in parentheses, the square root of, open parentheses, y1 quantity squared plus, and you can either do -2 squared or you could just call it a 4 as long as you don't screw it up, close the parentheses, with respect to x from 0 to 1, plus function integrate, open the parentheses, square root of, parentheses, y1 squared plus 0. You don't need the plus 0, but if you just want to play it safe because you're afraid you might do something crazy, with respect to x from 1 to 2. And that's what I'm going to type in my calculator. So math 9, right, square root, there's over to function pick y1 squared plus 4, close the parentheses, comma, with respect to x from 0 to 1, close the parentheses, plus math 9, square root of y1 squared Again, if you want to write the +1, that's fine. If you or +0, that's fine. If you don't, that's also fine. +0, close the parentheses, comma, with respect to x, from 1 to 2, right? Okay, so if we double check that real quick, right, it's a whole big mess, but let's double check. So function integrate, the square root of my x prime is squared plus 4, correct? With respect to x from 1 to 0, plus function integrate, the square root of my y1 is my x prime squared, plus 0 with respect to x from 1 to 2, and I hit enter after all of that craziness, and I get that this is a 4.349 or 350. Either of those are fine. So the AP needs to see this. They don't care about the notation stuff that you use in the calculator, but if you don't understand how to put in a calculator, then you're going to have a problem, right? So, and that's my answer, right?